Before we start running the program, we will want to navigate to the source folder and then resource and config properties. In this file, you will want to edit the local SQL URL, local database username, and password. And this will connect you to the local MySQL database. And then navigate to misc enum and find the data.sql file. Run this SQ file in the local database to generate all the data we need during our play session. And after all that's done, just double click the jar file to start the program. So when we start the program, we will be at the login page. For robustness, we have limited the user's input. The username will only be integer. If the user tries to put in an alphabet, we'll have a warning that says username must be numeric. Also for password, you cannot have any special characters. If I put in like a special characters, it'll tell you can only put in letters and numbers. We also have two types of user, player and system admin. They will see different UI based on which type of user they are. So we're going to use user 1, and the password is pwd123. This is a regular player. So this is the screen they will see when they log in. We're going to close and restart the program again. For today's demo, we're going to use an admin user. Username is 3, password is test. Okay, as you see, when we log in, we have a new button called Admin Dashboard. This is only visible to the admins. We're going to quickly go through the battle to show the core functionality of our program. So when we click battle, it brings you up to the Pokemon selection page. You're allowed to select one Pokemon from the page, Pidgey. And then you're also allowed to set a seed over here. When the seed is set, you can also remove it by clicking the delete seed button. And now we're going to set that again. And then when you click fight, it will find a random Pokemon in the database and fight against it. And as you can see, there's defense spells, there's attack spells, there's weakness, there's power. Okay, whenever one Pokemon HP is reduced to 0, that means the battle has ended. Okay, now we can exit the battle and the battle result is saved. The other functionality is a tournament. You need to select at least 4 Pokemon, and also you can set a seed and start a tournament. So the tournament will basically start the battle between random chosen 2 Pokemon, and it'll keep going up until there's a final winner. We're gonna skip the process here by going to the next battle. This is battle number 2. Oh, this battle, I think this is the last battle, yes. Okay, so Pidgey has fainted. Now we are at the end of the tournament, and I'll show you who is the winner of the tournament. Each user can also click the My Pokemon page to see which Pokemon they have. And then they can also click the Pokemon details, which brings them to the details to page. Shows which skill they have, how many battles they win, and the basic status. Now we go back to the admin board. There are 4 functionalities in the admin board. For robustness, we have a error log. Anytime if the program errors out, we will write into the error log database, and the admins can go in here and see what exactly happened. Those are example data, but when real error happens, we will write it here. We also have command log for admins to see what exactly happened during each battle. We store the commands into the database. For example, we have the battle between Pidgey and Charmander, which is the one we just fought, will be stored in the database. Cool. We also have the battle results board. Every time when a battle ends, the result will be stored in database as well. For example, the Charmander versus Pidgey one, You can see the Charmander has lost the battle and what is the seed number and battle ID and etc. Cool, and lastly we have a create Pokemon functionality. By clicking this button, inputting a Pokemon ID, name, all that information in there, and then click create Pokemon, and it'll show Pokemon created successfully, and it will directly insert into the database. Now if we go to the Pokemon database, we'll see that the test Pokemon is already in there with the ID of 213214, which is what we just inputted. One of our main focus is robustness. Therefore, we introduced a dedicated battle log class and a battle log writer, which supports a 2-tier persistence. It saves the log both locally and inside the database. I already show what it looks like on the UI inside the database, and now I'm going to show how the logs are saved locally. There are 3 items that we saved locally, really 2, because the battle and the tournament log are basically the same thing. I'm going to open up one of them. So this is the battle log, every single line of what happened during each battle. And this also allows the admins to go in there and see what if there's any illegal moves or if the player is cheating or etc. So the tournament log is essentially the same thing, except it stores more battle because each tournament can contain more than 1 battle. But all the information is also stored in the JSON file. And lastly, we have the command history. This is basically a short version of the battle log. So whenever user starts a battle, we will add 1 line to the text file. And with those information, we will be able to rerun and replicate the exact battle history. We can rerun this command and compare with the battle log and see if it generated similar results. In conclusion, the battle log system demonstrated how we approach robustness through thoughtful design. We used event bus to achieve loose coupling and asynchronous communication. We also followed the single responsibility principle by separating the log logic from the game logic. And we also implemented a dual channel login to local files and to the database. We made all the storage operations exception resilient, ensuring the system can continue even under failure. The other focus of our project is skill modification. In our battle system, each Pokemon and each skill is associated with a specific element type. Each Pokemon also has 2 element attributes, a strength element and a weakness element. The strength element represents the type that Pokemon naturally aligns with, and the weakness element indicates the type it's vulnerable to. So I'm going to do a battle to demonstrate. Let's choose Charmander. Okay. So it says Charmander has no elemental restraint between Abra and Charmander. So this battle, all the damage will be normal. But in case there is a elemental restraint, if the Pokemon's strength element matches the other Pokemon's weakness element, all the skill damage will be +1 for the Pokemon with the advantage element. Also, if the skill of the Pokemon uses is the same element as the Pokemon itself, then the damage will be multiplied by 1.5. For example, you see here, Abra is attacking with Flamethrower for 6 damage. Charmander is attacking with the same skill for 9 damage, because the Charmander and Flamethrower has the same element, while Abra and Flamethrower does not have the same element. So, overall, this system introduced elemental dynamics in a clean, logical way. It rewards thoughtful skill selection, and it mirrors the intuitive relationship found in traditional Pokemon games. It also implemented a way that's modular and easy to extend to future enhancements. Okay, lastly, we will talk about our overall system design. Our entire system is designed following the Model View Controller MVC architecture pattern, promoting separation of controls, modularity, and maintainability. At the view layer, we're using Java's default GUI package Swing, which contains all the visual components that we need. All the pages you see, this is the battle page, this is the main page, admin dashboard, are all built with the Java GUI. Every time user clicks a button or typing anything, it sends a call to the controller. Our central controller class is called the game controller, which basically connects the GUI and the backend logic. Okay, the model layer is subdivided into multiple functional components. So the domain folder contains the core game logic, including the battle, results, and tournament. These encapsulate the rules of combat, tournament flow, and outcome recording. The Pokemon folder contains battle, entities, and behaviors. It includes an iPokemon interface and its implementations, as well as skill structure and elemental attributes. The DAO layer handles data persistence, allowing interaction with MySQL through classes like Pokemon DAO, results, user DAO, and errorlog DAO. And the entity folder contains objects like user, Pokemon info, skills, which represents the database object structure and mapped directly from the query. This layered architecture ensures that logic presentation and data access are clearly separated from the controller and from the view layer. Each component can be developed and tested independently, while changes in the UI or database structure has minimal impact on core battle mechanics.